All right, just wanted to give you a little music back there. That song's called Scatterbrain, and it just reminded me because we are talking about scatter plots here. There we go. Just had to fix my mic there. Yeah, so scatter plots and predictions today. So I gave you a little musical intro with the song Scatterbrain. Hope you enjoyed that one as much as I did. Anyways, let's get back to it. Section 4.5, scatter plots and predictions. So our objective, as you see here, a couple different things. We're going to interpret points on a scatter plot and then write an equation for the line of best fit. So we've got two things we want to accomplish there. Interpret points on a scatter plot, then write the equation for a line of best fit. So what is a scatter plot? Well, it's a graphical representation of data involving two variables. Okay. And then we've got a couple different sub things underneath it. It can show a pattern in the data. If there is any pattern, sometimes there's not. And we can use this to make predictions. And we've got two different variables. Remember, so one good one, and we talk about this a lot, and it'll be our big example for the section today. But if we go, say, one variable being the time spent studying. If we say time studying, and then on the other variable would be your test grade on the other axis, test grades. Okay, and in this case, you might have, say some dots all over the place here. If we took everyone in the class and gave them a general idea here, I'm just put a whole bunch of dots on there. But generally what happens here is you end up getting all the data just kind of speckled in here in a scatter plot with all these dots. But you can kind of look and see that generally that the more time we went studying, the dots kind of went upwards for your test grade. So there is a general prediction you could make. And I already kind of put that one down here, but the line of fit here would be the line that fits best through all the data points. So in this case, if we were to kind of take draw a line, it's not going to touch all the points, but we could draw a line that said, all right, kind of goes through here the best we can, kind of. I mean, it's not going to touch all the data points, and that's what the second thing here under line of fit says is the line of fit will not touch all the data points, but it's kind of close to them, and we're going to use that to kind of make a prediction as to what would happen if you spent more time or spent a certain amount of time studying. Your prediction equation, and that's kind of what we're getting to get the line of fit. This will vary, answers are vary because we're estimating. We don't actually have the actual data. We're going to estimate what it would be at a certain point because of our prediction equation. And then the second thing is, how do we do this? We're going to find a slope and use a point from the graph. So we're going to find a slope and use a point from this graph. And we'll talk about, there's different strategies on how to do that, and we'll help you through that as we go. Some correlation stuff. There's different correlations. There's positive correlation, negative correlation, no correlation. There's also a weak correlation if it doesn't show much of a connection. You guys already have these graphs in front of you, so we'll just take a look at those and what they mean. First, this positive correlation. You can see it's a positive correlation because, number one, it has a positive slope. If you were to draw a line through here, the line of best fit here, it'd be moving upwards. So there's a positive slope. That's number one. And then we could talk about it, say, as x increases, then y increases. Or if you actually wanted to use the terms from the x's, as the years go up, as time went by, the dollars went up. More money was made for personal income. You could have a negative correlation, where you have a negative slope. So as you can see here, this line here is going down. If we had a line of best fit, it would be going down. That has a negative slope, so that's a negative correlation. And this one's just the opposite. As x increases, y decreases. Or we could use the terms from our axes here. As time goes by, as the years go by, we have less and less students sharing computers, meaning everyone has more of their own computers that they're bringing to schools. Now with all these programs where people are giving iPads out and stuff. And there's also a weak correlation where there might be a correlation, but maybe there's dots all over the place on each side. There, you could still find a line of best fit, but there might be dots on each side that are kind of outliers. And we'd say maybe it's a weak correlation. These two are pretty strong correlations because the line of best fit's right next to them. And then we've got this one here where there's no correlation with the dots everywhere. There's not really any way to find slope or find a line of best fit because there's just no way that you could make it fit all these different data sets. And then we could basically say then that X and Y are not related. The X had nothing to do with the Y, or vice versa. The Y had nothing to do with the X. Okay, so that takes us to the next step here, where we're talking about independent and dependent variables. So, like we said, this last one here with no correlation, this last one here with no correlation, you can't really put a line in there, and you can't make a prediction, and you can't say that Y depended on X, like we're going to talk about here, dependent and independent variables. So we know those. We've talked about these before, that your X values are the independent values. Those are the independent variables. Also, we've used the term domain with those. And then we've talked about your dependent. Remember, those are your Y values, saying that the Y depends on the X. The Y depends on the X. And we've also used the term range, domain and range. So we've talked about those before in the past. And if we took a look at, say, these correlations here, okay, in this one here, the year, or the dollars depended on the year. The years went on, we had more income. That was dependent. And over here, the students per computer, that was dependent on the year as well. And even our example over here with the time studying, the more time studying, well, that determined your test grade. You can see the test grades went up as we studied more. So the test grades depended on the time spent studying. So that's why we got dependent, independent variable. Some terms here, interpolation. What does that mean? That means we can predict values inside the range of data. So let's just give us a little table as well. So we talked about how we've got two axes, and we talked about down here, your X, that's going to be your independent variable, right? And up here is your Y, is going to be your dependent. Okay, independent versus dependent. And so our interpolation is predicting values that are going to lie inside this range of data. Somewhere in here is going to be interpolation. We can interpolate stuff. Okay, I'm just kind of showing that to let us know, again, what that means. And so say, for example, we had a list of time from, say, the year 2000 to the year 2015. Well, then we could make predictions. Somewhere in here would be the year 2010, and we could make a prediction about what would happen there. That's called interpolating. Okay? Extrapolation, linear extrapolation. We're going to predict values that are outside the range of data. So in this case, what we're doing is we're saying, all right, using the same graph, but now let's say if we use the same example, 2000 to 2015, we could predict something that happens in 2050 or 2030 or 2020 based on what kind of line we're going to get with our line of best fit. So if all of a sudden we had this line of best fit that comes through here, we could predict, it's not inside the range of data, it's outside the range of data. So we would say, all right, as this line continues, where's it going to be in 2025? Where's it going to be in 2040, 2060? So extrapolation is predicting outside the range of data, where interpolation is predicting inside the range of data. All right, how to create a scatter plot. And then we're going to kind of do our practice problem, our lesson summary and practice problem as one of our practice problems here. So the first thing we got to do is collect the data. So I will provide that for our practice problem lesson summary. Whatever data we have, that's what we'll do. And then we're going to graph the data on graph paper. Graph the data on graph paper. And by doing that, we have to, of course, then look at our graph, and we have to decide on your x and y axis. And just remember which one's the independent variable, which one's the dependent variable. Those are the ones we have to look at. Decide on your x and y axis. Then we're going to draw the best fit line. Not dot to dot, we're going to draw the best fit line. And then we're going to do that. I'll show you how to do that by using some slope and making a linear equation and being able to graph it. But we're not going dot to dot. We're going to kind of go through the dots. As you see on, say, this one. I didn't touch every dot on this one here. These lines here did not touch every dot. And our very first one did not touch every dot. So you're not going to go dot to dot here. What we're going to do is we're going to draw the best fit lines. Goes through. How are we going to do that? Well, we got to find the slope. We're going to pick 2 points on the best fit line. Okay? So we're going to draw the best line we can. We're going to pick 2 points on that line. And basically, we're going to pick the second point and the second from last point. And this is no like scientific theory or anything that makes it work. It's just this is what I'm telling you to do so that we all have the same slope and we all have the same lines that we're dealing with, the same coordinates. If not, we're going to be dealing with 25 different slopes and 25 different coordinates. So if we all pick the second point and the second from the last point, then we'll be in good shape to go. From those points, now we can use the slope formula. Find the slope, which we should know how to do. M equals y2 minus y1 over x2 minus x1. Should be able to handle that. That's why we've been doing it all these times. So now you have 2 points. One will be the second point, one will be the second from the last point, and that's what you can plug into your slope formula. And then we're going to use point-slope equation. Use point-slope equation. From those points, pick one of those points. You can use either. You're going to get the same answer for either one, whether you use the second point or the second from the last point, and plug it into point-slope form. And then we want to solve for y, which basically means we're going to put the answer into slope-intercept form. Which is y equals mx plus b, of course. So after we found the slope, we can use one of those points, one of the 2 points we picked, and that slope to put it into point-slope form and solve for y, basically put it into y equals mx plus b form, and that would be your final equation. Okay, so this will serve as our lesson summary practice problem here. And I'll kind of just go through it with you. Tell you what you have to do, and that'll be it. Okay, so the table below shows the number of minutes that 18 students studied and their test scores that they earned. Use this data to answer the following questions. So you've got all these minutes here, and you've got all these scores. Basically, that's your data. So that first part, collecting the data, it's already been done for you. Okay, the first step, collecting the data, we've already done that. Okay. Identify the dependent and independent variables. What do you want to be your independent and dependent variables? Then draw a scatter plot of the data. So that's the graphing part. Draw a scatter plot. And just to kind of help you out on that, I think it's be best if on your x-axis down here that you went by tens. Count by tens. And then here on your y's, let's count by tens as well. I think tens works. You might actually have 1 or 2 points that go off of the x-axis here. That's fine. That's fine. But I think if you count each of these grid marks as tens, so 10, 20, 30, 40, 50, then I think you'll be in good shape to graph these scatter plots, or to graph this data and make a scatter plot. All right, then we're going to draw a line of best fit. Do the best thing if you can. Okay, and then we're going to determine, is there any correlation? Make a prediction. Do you see any correlation? Is it positive? Is it negative? Is it strong, weak? What's the deal? And then write the prediction equation in step 5. So in step 5, Writing the prediction equation, remember, you're going to need the 2 points. So we're going to use, again, the second point here, and then the second to last point. So these would be your 2 points that we'll use when we talk about down here, picking 2 points. So we've already collected the data. We're going to graph it on there. We're using tens, draw the best fit line. We're going to pick 2 points there, the second and the second from the last, which we already did. Okay, 15, 65, 90, and 100. You got to determine your axis here. Then after that, we're going to write that equation based on what we have. So we're going to find the slope with those 2 points. We're going to then plug it into point slope form and get it into y equals mx plus b form, and then all of a sudden you've got your prediction equation. From there, let's take a look at interpolating and extrapolating. We're going to predict a score of a student who scored 25 minutes, where 25 will be in your range of data. So you can make a prediction based on your equation, what would happen in 25 minutes. And then extrapolation, we're going to predict a score of a student who studied 5 minutes. 5 minutes. Remember, that is not in your set of data. Minutes, the lowest minutes is 10. 5 is not in there. So we're going to make a prediction on what would happen if you only studied for 5 minutes. Okay? That is it for section 4.5 on scatter plots and predictions. Get this done and bring it in, and we'll ask questions tomorrow.